Hello everyone. Am I audible? Please confirm in chat box. Very good evening to all of you. Please confirm if you are able to hear me. And is my slide visible? Yeah, okay. Fine. Rahul and Anupam, thank you for your response. So this is Brahmastra Series. Today we are going to discuss Unit 1A and 1C. So what do we have here? In Unit 1A of CSIR syllabus, we have structure of atoms, molecules and chemical bonds. And under 1C, we have stabilizing interactions in macromolecules. So these are very basic units, but sometimes question also comes from here. Yes, very good evening, Anusha. So good evening to all of you. Now, what kind of questions come? For generally part B questions, okay? You don't get to see more part C questions. Mostly it will be short part B questions, but some conceptual things you can get part C also. I'll be discussing both today, right? Let's go on to the first question. In a crystalline NaCl, how many chloride ions surround each sodium ion? 4, 6, 8, 10. What will be the correct answer? So this is from subunit 1A, where you have different type of bonds like covalent bond, ionic bond, and also the types of molecules. So what do you think will be the answer over here? First of all, tell me what is NaCl. In NaCl, obviously sodium is an element, Cl is an element. So between them, what type of bonding is formed? Sodium is a metal, Cl is a non-metal. So between them, what type of bonds form? Okay, I'm getting all type of answers. 1, 3. We haven't started this. Yeah, that's because this is regarding Unit 1. Okay, don't worry. We will be starting with Unit 5. Okay, you're saying option 1. Okay, so first of all, tell me what type of bond will be there between sodium and chloride. Sodium is a metal and chlorine is a non-metal, isn't it? So between metal and non-metals, what type of bonds are formed? Yes, very good. Um, Ishrar and Nimisha, very good. Yes, Anupam also correct. Yes, Sagarika, that's the right answer. Yes, Rohit also correct. So it is ionic bond, okay? Now, how is ionic bond formed? Between ions, it will be formed. Ionic bond will be formed between ions. Okay, so ionic bond results from the complete transfer of electrons. Complete transfer of electrons from one element to the other element. So when this happens, we have the generation of some ions. So sodium has one electron in the valence shell, that is the outer shell. So if I have to draw the sodium atom, I'm not drawing the inner shell. So in the inner shell, you're having 2 electrons, then you're having 8 electrons. Okay, I'm not drawing all that for chlorine, just showing you. And sodium has this 1 electron in outer shell. Now chlorine on the other hand, so similar to that, it has 2 over here, it has 8 over here, but then here it has 7. Okay, so 7 electrons are there in the valence shell, and it needs one more electron, so that it takes from sodium. Now when this happens, it leads to the formation of ions. Chlorine becomes chlorine ion, okay, and sodium also becomes sodium ion. But however, since you know in an atom the number of positive charges is equal to the number of negative charges, okay, so if you are taking out an electron which is negative charge, the positive charge increases. And that's why, since you have taken out one electron, you get only Na plus. And if you get this one electron over here, this becomes Cl minus, which becomes which takes one extra electron, because of which it becomes Cl 1 Cl minus, right? Now these ions, since they have opposite charges, they stay together. So that is called as electrostatic attraction, and since it's a bond formed between ions, it's called as ionic bond. Now, very important characteristic for ionic bond is that all type of generally ionic bonds, they exist as lattice, that is crystal. Okay, they will exist as lattice or crystal. Now here what happens, especially in sodium, one sodium will be surrounded by 6 chlorine like this. So first of all, if you are able to understand, let's say okay, this sodium, okay, so it is surrounded by all its sides, okay, by the different chlorine atoms, and even on the sides also. So even on the sides also, it is surrounded by the chlorine atoms. Okay. Now, why ionic compounds stay in lattice? It is to maximize the interactions between them. Okay, maximize the interactions. So, as you know, we are discussing mostly CSIR questions only, and today in my session, all are CSIR questions only. So this is a part B question from CSIR. Okay. Even if you feel who will ask about this chemistry things, ions, molecules, bond. But as you can see, this type of questions have come already. Okay. Sodium chloride crystal consists of Na plus and Cl minus. Each Na plus ion is surrounded by 6 chlorine ions and vice versa. Even chlorine ion is surrounded by 6 sodium. Okay. So coordination number, we call that it is 6. NaCl is a very common molecule, that's why they have asked it. But generally, for uncommon molecules, you'll not get. But probably that ionic bonds, they have such kind of property to form the lattice. Okay. Moving on to the next question. The interaction energy between two opposite charges separated by 3 Armstrong in vacuum is minus 500 kilojoule per mole. The interaction, the energy between these two charges in water will be closest to what? Not to read, which topic not to read from unit 1? Anupam, you can ignore colligative property. It doesn't come in exam at all. And you can also leave, if you want, you can also leave reaction kinetics. That question also is very rare. Okay, hardly in 2-3 years, maybe one sub part of question will be there. And apart from that, you have this metabolism of lipids, especially the synthesis part. It's not asked. Okay. um, Metabolism of lipid catabolism, still one or two question might be there. Okay, in 2-3 years. And amino acid metabolism and vitamin metabolism, again these are not that important topic, because the intensity, the repetition of question is not there from here. Okay, you don't get much questions from here. Okay, so we are calculating here the interaction energy between two particles. Okay, so there is an equation which defines this interaction energy between two particles. Who can say what equation is that? Yes. What type of interaction energy we have? So we have a very popular equation for explaining this interaction energy. No one? Okay. So it is called as Coulomb's law. Have you heard of it? Coulomb's law? At least give it a try. What do you think? Like in vacuum, so Coulomb's law is given by Q1 by Q1 into Q2 divided by R, where R is the radius, Q1 and Q2 are the charges, the opposite charges which are there, and R is the radius. Okay. So if you have in vacuum and if you have in water, then at least can you guess that particular charge separation? If you're in evening batch, this unit has already started, Saujanya. So minus 500, and if you're in morning batch, don't worry. Next sessions, when I come for your YouTube session, I'll be taking Unit 5 for you, okay? So that time we'll discuss Unit 5. All right? Yes. Others, evening batch students, and even any other students who are attending over here, at least you can take a guess. What is the energy between two opposite charges? It will be more in water or it should be less in water? So you must be aware of polar and non-polar molecules, isn't it? Right? Polar and non-polar molecules. What do you call as a polar molecule? A polar molecule has a polar covalent bond. And polar molecules, example, you can take as water, right? So you have this hydrogen, which is having delta positive charge and delta negative charge for oxygen, right? Yes, having dipole. Exactly, Anupam. Very good. So this is what they are having, the dipole moments. This is a polar molecule, right? Now, if you have opposite charges, it has said between opposite charges, plus minus is there. Even in water, plus minus is there. So then interaction should be more in when in presence of water or less in presence of water. These are also charged. This is also charged. Opposite, like partial charge is there. This is called as partial charge. So charges will like charges, no? So when in water, the interaction will be more or less? Tell me. When in water, the interaction should be more or less. Yes, Sagrika, you understood now, right? Yes, Sushant, what do you think? What about the others? Yes, it should be more. Very good. Sunshine, Sushant, very good. It should be more, right? So if it is more, okay, then that means this cannot be the answer. Anyways, there is a formula how to do it. Okay. So let me show you. Yes, Rohit, very good. It will be more. So let me show you how to do it. This is Coulomb's law, right? Coulomb's law is the force is equal to constant into Q1 into Q2 divided by R square. So this is the radius. So if you keep on increasing the radius, since it is in the denominator, the force will keep on becoming lesser and lesser. Okay, if you keep on keep increasing the distance between them, right? So when you take for vacuum, so this force, this constant is given by this symbol. Okay, this K constant is given by this symbol when in vacuum, means this expression. But when you take in medium, this constant, it will be also multiplied by epsilon r. So epsilon r is the dielectric constant value in media. Okay, you have to put dielectric constant in media. Fine. So for vacuum, actually here also you have ER, but since it is 1, we don't take into consideration. But here ER for water, that is in media, we are using in questions water. The epsilon value is 78, close to 80, because dielectric constant of water is near 80. Dielectric constant is a measure of the hydrophilicity of the media. More hydrophilic the media, or more polar the media, you must say, more polar the media, more will be the dielectric constant. So since water is polar, dielectric constant is also high. It is somewhere near 80. Okay, so all you have to do is, so this is what you get. Rest all remains same. So if you have the interaction energy in vacuum, if you have the interaction energy in media, that is in water, the only difference is your dielectric constant. So everything gets cut off. If you take the uh, the media divided by the vacuum, the force in the media divided force in vacuum, all you're left with is the dielectric constant value. So how much you're supposed to calculate this, right? So you just bring the other term over here. So you have to just divide. Minus 500 divided by 78. Answer will be minus 0.64 kilojoule. So correct answer over here is option 4. Okay. See, all you need to do over here is minus 500 is in vacuum. So all you need to divide is by the dielectric constant. That is what you will be getting in water. Clear, everyone? Is this question clear? How to solve such kind of questions? You just need to um, you need to know the dielectric constant of water and the Coulomb's law also. Okay. Okay. Next question. So match the following with their approximate energies. We have different type of bonds: hydrogen bond, van der Waals forces, then covalent bond, ionic bond. Now just I already told you how covalent bond forms, ionic bond forms. Bond forms by sharing of electrons. See, these are chemistry basics basically. Okay. Even if unit 1 is not started in morning batch, but at least you must be knowing basic chemistry things, right? That is, covalent bond is formed by overlap of orbitals by sharing of electrons. And hydrogen bond and van der Waals forces are non-covalent interaction. They are very weak, right? So their energy is very weak. I've already given you a hint, so at least you can take a guess and try to solve this question. This is a part C question. Okay, and this type of energy based questions, they come a lot. I mean, such kind of questions are quite repetitive. Okay, Anupam, let's see. Yes, anyone else wants to try? Come on, students. Match the following questions are best in CSIR. Even if you don't know the others, you can at least take some amount of guess. Okay, one or two you can match means the rest automatically you will be able to figure out by the options given. Okay. Okay. First tell me, out of all this, which one do you think is the strongest? First tell me that. Out of all this, which one do you think will be the strongest bond? Out of all this, what do you think will be the strongest bond? Yes, very good, Anupam. So it will be covalent bond, isn't it? So covalent, you can see out of all these energies, 80 is the highest, isn't it? So covalent bond will be with 80 kilocal. Okay. So Rohit, there is a contradictory statement that ionic bonds are have more strength than covalent, which is in a way right. Okay, because I'll tell you why. Because when it comes to ions, their range is very high. Like you have very low energy ions also, very high energy ions also. Okay, but generally in such type of questions, you have to follow that covalent bond is strongest because we are considering the mechanism of the bond, and also we are considering a general strength. Okay, all ionic bonds are not stronger than covalent bond, but many covalent bonds are stronger than the ionic bonds. Got it? So that's why Richa and Rohit will consider ion covalent as strongest. Okay, and least is van der Waals. Very good, Anupam. So least will be our van der Waals force. So least is what? 0.5. Okay, because van der Waals force, the lizard, how does it hold on to the walls, right? So the reptile. Yes, Jagdish, very good. Covalent is strongest, and your answer is also right. Okay, Anupam, your answer is also right. The answer is sorry, not Anupam and Jagdish, Nimisha and Surendra, even Rahul also, and Sunshine, your answer is right. Okay, so it is option is 4. Now let's see how van der Waals will be the weakest. Okay, so B has to be 1. So C is 3, B is 1. Now let's see here also, like that is there. But now we have to find between ionic bond and hydrogen bond. So ionic bond is formed with the opposite charges. As I gave you example, sodium plus and Cl minus. Okay. Yes, Sunshine, that's right. Very good. In biological system, covalent bond is stronger than ionic. You are absolutely right. Okay. So Na plus and Cl minus, they are opposite charges. So their interaction energy will be higher. Okay. But hydrogen is considered a type of van der Waals force. So van der Waals force are many types: dipole, dipole, iron dipole, dipole induced dipole. Okay, but van der Waals force, in that you have a dipole dipole interaction, that is a special type of dipole dipole, is only what is hydrogen bond. Okay, just that its strength is more. A special type of dipole dipole is a hydrogen bond, just that its strength will be more. Okay, so that's why here you can see the covalent bonds, their bond strengths are the highest over here, right? Examples are given. Non-covalent interactions. So next you have ionic interaction. You can see 40 to 400. You have huge range over here, right? And then you have hydrogen bonds. They are to some extent like this. And van der Waals interaction to some extent like this. So all these are explanations of van der Waals interactions only, like this iron permanent dipole, iron induced dipole. Don't get confused with the word dipole. Dipole is nothing but a covalent bond. Okay. So, for example, you have HCl. So, HCl, hydrogen is less electronegative, so it gets delta plus. Cl is delta minus. Okay, fine, Jagdish. Okay. So, this is creating opposite pole. That's why this particular molecule is called a dipole, which is having a polar covalent bond. So if you have polar covalent bond, it is called as a dipole. Okay, so even this was CSIR question only. Fine. So this is how covalent bond is formed. When when two atoms are sharing electrons. Okay, this is atom A, this is atom B, in which both are in need of one electron. This A needs one more electron to complete its octet. B also needs one more electron to complete octet. But if B gives one electron, then it will be short of two electron. Same if A gives, it will be short of two electron. None of them can complete. So as a result, both of them share that two electrons. Okay, so these two electrons are common between A and B. This requires overlap of orbital. That's why it is very strong. Okay. On the other hand, ionic bond, it requires transfer of electrons. So atom A has one extra electron, atom B has is in the need of one electron, so it will transfer the electron to atom B. Okay, with that you have the generation of ions. You have the positive charge ion and the negative charge ion, which stays together as ionic bond. So with the general mechanism, covalent is stronger. Moving on to the next question. Solubility of gases in water, it depends on the interaction with water molecules. They have already given you the statement based on which you need to solve this question. Okay, it depends on their interaction with the water molecules. Here you have four gases. So in terms of the solubility, which one will be correct? So you have to find out which is the highest one, which is the lowest one first. Then you can figure out the least, the others. Okay. Now again, it has a similar mechanism of solving. Water is polar molecule. So I'll give you a hint. Like dissolves like. That means same type of molecules will dissolve in each other. Okay. Okay, Sagarika, Anupam, Nimisha. I'll tell you whether your answers are right or wrong. Good, you attempted. So like dissolves like. Right. So if you have to if you have to understand that what will dissolve in water, that means you need to find out some polar molecule. Okay, yes. Suresh, Sunshine, good, you all are trying. Very nice. Yes. So we need to find out which is the most polar molecule. Most polar molecule will be most soluble in water. Least polar molecule will be least soluble in water. Yes, Rahul. So actually all your answers are right. Very good. Okay. Now, see if you take oxygen, okay? So oxygen, it has like this. So this is a completely non-polar molecule because it doesn't have any partial charge. This is also delta zero, this is also delta zero. No partial charges because both have equal strength of attracting electron. So both of them will be pulling with equal force. Okay, Richa, I'm explaining. Just look here. Why oxygen is the least? Okay, it is the least polar molecule. Okay, and I told you like dissolves like. So water is polar molecule means any polar molecule will only dissolve in it. Okay, so oxygen is non-polar. That means it is least soluble in water. Got it? So there itself you can have your answer. Now the others that you have, ammonia. Let's talk about ammonia. So nitrogen and water. Okay, means nitrogen and hydrogen. So this is what is ammonia with a lone pair of electrons. Now you need to know what is the electronegativity difference between nitrogen and hydrogen. Okay. So if you see, this is the electronegativity chart. Electronegativity is nothing but the capacity to attract electron towards itself. Okay, capacity to attract electron. So more the electronegativity, more is the capacity to attract electron. Okay, for example, this oxygen, nitrogen, they have very high electronegativity. Fluorine, but the metals, they have very low electronegativity. That's why, when sodium and chlorine combines, sodium has very low electronegativity and chlorine has very high electronegativity. That's why chlorine takes away sodium's electron. Okay. Now, more the electronegativity difference. If electronegativity difference is there, then one element will pull more than the other element. Okay. For example, I told you in NaCl. Now, next example you can take in carbon and oxygen. Okay. Then you can take between oxygen and hydrogen. Okay. So the difference between oxygen and hydrogen is more. That is why in water you have more polarity because the difference is more. So oxygen will pull the electrons more than hydrogen. That's why oxygen gets a delta minus. Okay. If you take carbon and oxygen, okay, so yes, the difference is there, but a little lesser than hydrogen. So this is a lesser polar molecule. If you take NO, so NO means there is hardly any difference. Okay, this is almost equal. So NO2 will be less polar. Got it? So CO2 will be more soluble than NO2 if you at least have those. Okay. Now let's see in the question you have. Now you understood why ammonia will be highest and why oxygen will be lowest. If you see ammonia, that is NH3, right? So you see your N and hydrogen. So difference is almost 1. Okay, so that also is a very highly polar molecule. So it will be soluble in water. Means not highly polar, but it is at least more polar than the others. Okay, because you have to look at the shape of the molecule also. So it has got a shape like this. That's why it is more polar. Okay. Now the other two are dioxide and carbon dioxide. Now let's check why sulfur dioxide and carbon dioxide. Now here the electronegativity difference is same. If you see between carbon and oxygen and if you see between sulfur and oxygen. Okay, both is one difference. But why then the sulfur dioxide is more polar? The reason is because sulfur dioxide is a bent molecule. Okay. So, and in carbon dioxide, even if it is polar, their dipoles cancel each other because it is a linear molecule. Okay. But since SO2 is bent, the dipole don't cancel. So S is little bit S minus and S is little bit S plus with a lone pair of electron. Oxygen being more electronegative, it is delta minus. Okay. So there is a dipole molecule which is a polar molecule. Polar compounds dissolve in polar solvents such as water. Non-polar compounds dissolve in non-polar solvent like that of CCl4. Okay. Clear everyone this answer? You understood the reasoning behind it? So this was also a part C question only. Okay. So till now we have discussed two part B question and two part C question. Now let's look at the next one. Okay, so this is again a part C question. So you try to answer with whatever we studied so far. At least try Sayanti once. You just try. See, there should be at least one or two statements which you must be knowing. See, you all are from some life science background only, right? So here, even if you have not studied, at least I can say that any one statement at least you will be able to find out whether it is correct or not. So see, have you not heard of this statement that when a reaction is spontaneous, the free energy change delta G is negative? Have you heard or not? So delta G is negative when you have a spontaneous statement, isn't it? Right? So this is right or wrong? If anything is is having a lowering of energy. See, in biomolecules, remember, low energy is the most stable. Okay, if anything is lowering their energy, they will be more stable. And delta G is negative means what? Energy is lost or energy is gained? Tell me. Delta G negative means energy is lost or energy is gained? Yes. Suresh, Rahul, Richa, Surinder, Sunshine. Good, you all are trying to answer. We'll see the right answer very soon. Okay, Anupam. Yes, tell me. Delta G is negative when? When energy is lost or when energy is gained? When we will say it is negative? Let's say it is it is converting from A to B. Okay, if I say in this conversion, our delta G is reaction means what? Let's consider A to B. So it will be lost or not? Energy will be lost or not? If delta G is negative, yes, it will lose energy. Okay, negative means it is losing energy. Okay, so if it is losing energy means what? In this conversion, B gets to lower their energy. B energy will be low. Okay, and if B energy is less means this reaction will be favored. Spontaneous means which happens by itself without any extra energy. This type of reaction is favored. That is called as spontaneous. Okay. So yes, all of your answers are right. Sagarika knew something. Anupam. Okay. Sunshine, Surendra, Richa, Rahul, Suresh. Very good, everyone. All your answers are right. See, you are already getting it. Okay. Now, A is that's why correct. Okay. So you have to select all wrong statement, which means this cannot be the answer. Okay. Let's see. The interaction between, okay, first you tell me this is correct or not. If we know the different bond energies of different bond, it is possible to find out, deduce means find out, whether bond will be covalent bond or hydrogen bond. Sunshine, it doesn't consume energy. Okay, energy is lost. When we say delta G, delta means the change in energy. So change in energy, if we say negative, it means the energy is lost. Okay, yes, tell me. If we know the bond energies, is it possible for us to find out whether the bond is covalent or not? Covalent or it is hydrogen? Can we tell the difference? Yes or no? Come on, students. We have already solved a question based on this. Possible, right? So I just showed you the chart, isn't it? Yes, Suresh, Surinder, Sagarika, very good. Why not Anupam? I have told you, no, this chart I showed you over here. So from this chart, you can clearly see we have a difference in the energy levels. Covalent is very high, whereas hydrogen bond is only 10 to 40 kilojoule per mole, whereas covalent, you see, it is always in the higher side. So we can tell. Okay, got it, Anupam? Yes, Anupam, Sagarika, Sunshine, right? Got it, Anupam? So we can tell. All right. So that's it. C is also correct. That's it. B and D are your wrong statements. Okay. Just we discussed one question. Correct. So as I told you, directly or indirectly, you will get this energy type of questions in CSIR. Now, the interaction between two nitrogen molecule in the gaseous state is electrostatic. So let us find out how that is. See, this is a nitrogen molecule. Okay. Yes, Anupam, that's right. Nimisha, your answer is right. See here, these are the two nitrogen molecule. Three electrons are shared between them. Okay, three electrons are shared. So this is it means a bond formed between two elements which have same electronegativity. So they will pull their electrons with same force. Okay, so nitrogen molecule is a non-polar molecule. Okay, there are no polarity in this, and no ions are also not formed over here because they are ending up sharing electron. They are not completely transferring electron as in the case of ionic bond, right? So nothing electrostatic, no charges are there. Electrostatic means where there will be opposite charges, attraction. So how can there be anything electrostatic with a nonpolar molecule? So this is wrong. Everyone must know that when a protein folds in aqueous environment, a globular protein, then it folds with hydrophobic interaction. That is, the polar molecules will be on the outside of the protein and non-polar molecules will aggregate in the center of the protein. We know that or not, right? So as you can see here, you have all the, okay, first of all, this is the protein molecule, okay? And this yellow colors are the hydrophobic groups, correct? And these are the polar molecules. These will be polar molecules, right? So when the molecule is dissolving in, means it is folding in water. So you can see there is immediately hydrophobic aggregation. All the hydrophobic means non-polar groups are joining together, and that leads to the folding of protein. So hydrophobic interactions is very important in folding of protein. The water molecules are getting freed up because of that. Okay, so hydrophobic interactions are very important. It's written not important, so that's why it is wrong. Correct answer is B and D. Right, so this is also a part C question. Are you getting confidence that you will be able to solve such kind of question? Yes. Okay, that's good, Surinder. So let's move on to. Okay, before this, I forget. Let me just quickly tell you we have Watson scholarship, impact scholarship, which you can avail, but there is a deadline of 31st July 2023. Okay, so we have our number given at the bottom, and we also have our website stores.biotechnica.org. If you are attending the classes, obviously it will make a huge difference in your CSI preparation. These are just the YouTube question sessions which you are benefiting so much. So just imagine if you get the classes along with that, how much helpful it will be. And along with that, you're also getting the WISE scholarship program. Okay, so different types of scholarships are available, but it depends on the means what type of program you're applying, right? For biotech graduates, postgraduates, and professionals. The reason I wanted to remind you is we have a deadline. So if you want to join for um, for this session to clear your December CSIR exam, then you must hurry up. You can contact on these numbers as soon as possible because we have limited seats. So don't forget about that. Okay. All right. So a protein in 100 ml KCl, let me explain over here itself since I have already shown you the answer. KCl was heated and observed Tm was 60 degree. So what is Tm? Melting. midpoint of unfolding. Melting over here means it doesn't literally mean that the molecule will melt away, like how our chocolate melts, no? So nothing like that, that molecule itself will be disappearing. No. Here in biomolecule, melting means separation. So when we say, or unfolding, so when we say a protein molecule which is folded, okay, so melting point means the point, the midpoint of the temperature which is required to unfold the protein. So to unfold this, if 100 degrees centigrade is required, so then the midpoint of that 50 degree will be the TM example. Okay. Now, when you have 100 molar KCl, the temperature required to unfold is 60 degree. But if we have 500 millimolar KCl, so you have taken more salt solution. Again, KCl is nothing but salt solution. So if you take 500 millimolar KCl, you can see that the TM has increased to 65 degrees centigrade. That means it has become more difficult to unfold the protein. Initially, it was easier. 60 degree was a lesser temperature. But now you need more temperature to unfold the protein. So what can be the reason for that? Okay. So here it's a very important phenomena that we call this. Anybody knows? Like what happens to the protein in low salt concentration? What happens to the protein in high salt concentration? What do we call it? You probably might be knowing. No? So these are like from the stabilizing interactions. Now I'm not asking you the answer. I just want to know what is that procedure called as. When you increase the salt solution and then some changes are taking place in the protein. Denature is okay, but that technique of denaturing the not denaturing, it's actually precipitating. Okay. I'm sure when I tell everyone will be remembering it. Salting in, salting out. You remember? Salting in and salting out, right? So less salt concentration means salting in. High salt concentration means salting out. Okay. So see here what happens in case of salting in. Okay. Your protein molecules, first of all, the salt concentration is less. You have some plus charges, you have some negative charges, but they are not present in much amount. So your protein molecules, they are interacting with the positive and negative charges. So here electrostatic attractions, um, yeah, that's right. This is salting in, Shayanti. Okay. So you have the electrostatic attractions, okay, but not to a lot of extent. Like only a few of them are present, few salt is present. So few of them are interacting with some part of the protein. Okay, so that is salting in when the salt is able to get into the solution. Okay, that's why salting in. The salt is able to get into the solution and interact with the protein molecule. So little bit attraction is there, right? But when what happens when the salting out will be there? Okay, so over here, lot of positive negative ions now increase. The concentration of salt increases. Okay, so what they will do is they will go and interact uh, with the water molecule, because water is also polar. So initially you had water interacting with protein, you had salts interacting with protein, you had salts interacting with water, but they were all in minimum amount. But when it is too much of salt, now the ions will be interacting with all the water. Now, water was initially interacting with protein, but now the waters are not free. So, what happened? Electrostatic attraction has increased because of the salt. Okay, and if attraction increases, then repulsion will decrease. Initially, there was repulsion, but now there is a bonding between the water opposite charges to the salt opposite charges. So, electrostatic repulsion has decreased. Okay, And what happens is the protein molecules, they were initially interacting with water, but now they are not able to do so because the waters are interacting with the ions. And that's why the protein molecules will now move more closer to each other. Their nonpolar groups will stick even further. So there will be an enhancement of hydrophobic effect. Because of that, the proteins which were initially present in aqueous phase, that is in water, but now that water is saturated with salt, and the proteins because of that will precipitate out. Okay, that's why it is salting out. They will precipitate out. Because of the salt, the proteins are precipitated out. Got it? So that's why the correct answer over here happened. Hydrophobic interaction increased. That's why the proteins clumped together out of water and they precipitated. And electrostatic interaction increased. So interaction increased means repulsion is decreased. Okay, clear? So your answer will be option 1, right? Moving on to the next question. So this is about hydrogen bonding. Let me see if anyone can answer. So we have to say which is the weakest hydrogen bond in a given solvent condition. So definitely here polarity matters because more polar this dipole. I told you hydrogen bond is formed between dipole. So in all these cases, these are acceptor molecule and all these are donor molecules. Okay, donor molecule with hydrogen and then you have this acceptor. Okay, you have to give the weakest hydrogen bond, weakest. So more the polarity between hydrogen and the other element, okay, more will be the polar bond. More will be the polarity. All right. So correct answer over here is option 4. Yes, proteins will repel high salt concentration. So protein get precipitated, okay, in high salt concentration. Yes, Suresh, that's absolutely right. Shanti, did you get your answer? See, this is a hydrogen bond, okay, where you have a dipole, where the dipole hydrogen and the other ones are involved in a covalent bond. Yes, which are correct answer. Very good. And with the acceptor, you have lone pair of electron, where these are just having a weak interaction between themselves. This is a weak interaction. This is the hydrogen bond. Okay. So NH covalent bond is less polar than OH bond. NH covalent bond is less polar. Why NH covalent bond is less polar? Because you look at the OH difference. Oxygen electronegativity and nitrogen electronegativity, you remember, right? So nitrogen and hydrogen covalent bond will be less polar because nitrogen is 2.5. Okay, so oxygen is 3.5 and hydrogen is 2.1. Nitrogen is 3 and hydrogen is 2.1. So you can see the difference. Here the difference is more. So as I said, more the electronegativity difference. Yes, very good, Sagarika. So here electronegativity difference is more. That is why this is more polar. Got it? So when you have here, you have oxygen, hydrogen. These two are most polar. Okay, okay, and these two are least polar. But in these also, you have to figure out who is the. So I will write more polar. Okay, more polar. Okay, and this is less polar and less polar. Now out of that also, which is the least? Out of these two, which is more? Out of these two, which is the least? Okay, so therefore, the fractional positive charge on H plus is smaller in 2 and 4. That is, as I said, more polar and less polar. All of them are hydrogen bond, okay? Now, oxygen being more electronegative than nitrogen, so this is the bond strength. So, NH covalent bond is less polar. Okay. Now, more polar means more strong hydrogen bond, as the partial positive charge on hydrogen will be more, isn't it? But it is asking about weakest. So, in this also, if you see this one and this one, okay, since in this one oxygen is involved, so there will be a polar difference between the hydrogen and oxygen than in nitrogen and hydrogen. Okay, so this more and less is based on the donor molecule, but then you have to also see the acceptor molecule. So between this acceptor molecule, since this is oxygen, this is slightly more, and since this is nitrogen, this will be the least. Got it? Now out of this 1 and 3, can you tell me which will be most polar? Out of this 1 and 3, which will be most polar? So I think Kavita, you have, Anupam, you had given answer for most polar before. Yes, tell me. Out of option 1 and 3, so there are more polar molecules, isn't it? So they will have a stronger hydrogen bond. So out of that also, which one will be most polar? Yes, Suresh, very good. So the one which is with more polar molecule, that is with oxygen only. Yeah, very good, Saujanya. See, you're already answering. Yes, self notes are preferred for making unit 1. Okay, because there are so many things to remember, no? You won't be able to retain everything during exam. So it's better if you can make some notes, or you can use the Biotechnica concept tools. Conceptica concept tools, if you know, concept notes is there, concept cloud is there, concept this one table, concept wheel. Okay, so these are like quick revision tools. Either you make your own notes or you use these ones. You can contact our team if you want such kind of revision tools. It will be very easy in exam. Okay. All right. So can you answer this? It is based on same principle only. In a hydrogen bond, as I said, a hydrogen bond formula is given as DHA. So this is written as solid dash, and this is written as dotted dash. Solid dash means it represents covalent bond, which is considered a strong bond. Okay. And this represents a hydrogen bond, which is considered a weak bond. Now, they are asking for van der Waals. So, what do you think? This difference between D and A and the sum of the van der Waals radius. So, D is an atom, van der Waals radius is something beyond which, if they come, so this atom has a van der Waals radius, this atom has a van der Waals radius. If any atom comes beyond this, that is, it overlaps van der Waals radius, then there will be repulsion. Okay. So you can say it is the optimum distance in which it can have interaction. Okay. So when such kind of covalent bond form, remember covalent bond is sharing of electron. So as a result, what will happen? When electrons are shared, their orbitals overlap. So they come very close to each other, isn't it? So D and H has to be extremely close with each other. Forget about the van der Waals here because they are having a sharing molecule. So that's why they will be extremely close to each other. And the hydrogen bond also, it is comparatively weak compared to covalent, but at least compared to van der Waals, it is stronger bond, which means it also needs to be quite close to acceptor atom. Okay. So if you take the total DNA van der Waals radius, it should be less than the sum of the van der Waals radius. Okay, because here we are talking about a bond which is stronger than the van der Waals radius. Got it? So answer here will be option 3. For a hydrogen bonded complex, the distance between DNA is expected to be less than the sum of the van der Waals radius of DNA. Okay. All right, next question. So this is how you find out ionic strength. I'll be telling you this is an ion. Such kind of questions also you must know. The ionic strength of 0.2 molar sodium hydrogen phosphate. What will it be? So let me explain to you this one because this involves a formula. Or else let me just tell you the formula. Then you can solve it on your own. Okay. So, okay, sorry, I gave that. Okay. Anyways, let me tell you then. The ionic strength is half summation CZ square. Okay. Yes, very good. Sunshine, that's the right answer. Half summation CZ square. Now, what is this sum C? C is the concentration. So, in this case, the concentration is 0.2 and Z is the charge. Okay. Now, first of all, whenever you have ionic strength, that means it's an ionic bond. You have to divide into the ions. So this ion will be Na plus, okay, and HPO4 minus. This two charges will be there. But since 2 Na is there, so that's why it will be 2 Na plus. You have to write into ions because it's an ionic compound, okay. So now it is half summation of both of them, Cz square. So half into, now the concentration of this is 0.2 only. So that is C. Z square will be, so charge on this is plus 1. Okay. So this is plus 1 square. Okay. Plus 1 square into 2. Why 2? Because 2 of this is there. Got it? And summation is there. Summation Cz square is the formula. So you have to add this one also. So how much will be this one? Same. C will be 0.2 into, so this is minus 1 charge. So minus 1 into 2. Okay. So if you solve this one, then you will be getting 0.6. Did you get everyone? So correct answer is option C. Just check if you have got this calculation or not. Okay, shall I move forward then? Did you get it? Okay. So this last question, the maximum number of hydrogen bonds that can form between hydrazine, they've already given the formula, and water. So between hydrogen and water. Now you know for a hydrogen bond to form, as you can see, hydrogen bond questions have come a lot, okay? If you want hydrogen bond, you need a donor molecule, right? And you need an acceptor molecule with lone pair of electron. So you have to figure out in this molecule how many maximum number of hydrogen bond can form. Nobody? Okay. Okay, so I have a limitation of time, Sayanti. No problem. I'll just show you. This is the structure of hydrazine. Okay. See, we all know nitrogen has 5 electrons in its outer shell. So with 3 electrons, it is forming bond. This one also with 3 electrons, it is forming single covalent bond, and 2 remain as lone pair of electrons. Okay, 2 remain as lone pair of electrons. Okay, so that's why each of this hydrogen, this NH, it can act as a donor. Okay, even this can act as a donor. Okay, so hydrogen atoms which is bonded to nitrogen interacts with it. 2 nitrogen can be hydrogen bond acceptor. So this one can be acceptor. But if other 4 water molecules are bonded to 4 hydrogen, if these are already bonded, then this nitrogen, even if lone pair of electron is there, they cannot form hydrogen bond at the same time, because it can only act as either a donor or an acceptor. Okay, so if these are serving as the donors, okay, so they are attracting the hydrogen, then these lone pair of electron cannot attract any more water. That's why total of 4 electrons, 4 hydrogen bonds will be formed. Correct answer is 4. Clear, everyone? No, it won't be 0.3. You can just see the explanation over here. See, it will be 0.2, that is the charge, sorry, concentration. Then into 2, because sodium 2 will be there, no? 2 sodiums will be there. And plus 1, 1 divided, 1 to the power 2. Okay. And here you have 0.2, that is the charge. Then 1, because only one ion is there. And oh, yes, yes. So sorry. Students, I'm so sorry. Actually, you have 2 minus, because this was 2 Na plus, no? So here you will have 2 Na minus, right? Because when you have Na2HPO4, okay, if you separate them out into ions, then you will have 2 Na plus, which would mean that here HPO4 will have 2 minus. Since 2 positive charges were there, to nullify it, you would require 2 negative charges, okay? So this will be minus 2 into 2. Then you will get 0.6. Is it clear now? Sayanti, Saujanya, thank you for pointing out. Okay. Yes. Yes, Sayanti, that's right. Very good. So that's all for today's class. Okay. I'll see you in the next class with Unit 5. Thank you, everyone.